dear students, today I am taking session 11, that is the BSc program physics subject for third semester according to the syllabus prescribed by Rani Chennamma University. This session 11 includes the aberration, introduction to aberrations, types of aberrations, and in which we are going to have spherical aberration and its minimization in detail. The learning objective of this session is to study what is aberration, types of aberrations, spherical aberration, principle to reduce spherical aberration, and elimination of spherical aberration. At the end of the session, you can be able to answer the cause for aberrations, different types of aberrations, spherical aberration, the principle to reduce spherical aberration, and elimination of this. Now we'll come to introduction to aberrations. Do you know what is aberration? Actually, the function of lens is to form a perfect, bright and magnified images of the object situated on the axis and off the axis also. For this purpose, the aperture of the lens should be large so that the number of rays from the object as long as possible may enter the lens. Therefore, we have to consider both paraxial and also marginal incident rays. In general, non-paraxial rays of light from an object after refraction through the lens do not meet at a single point, and hence the refractive index and the focal length of the lens are different for different wavelengths of the light. Thus, the rays of white light after refraction through the lens form number of colored images. And if we are using a monochromatic light, then there will be change in size, shape of an image for an object which is at the paraxial or on the principal axis, or that means it is a point object or an infinite object. The image will be having different shapes. So, the aberration is said to be the departure of real image from the ideal images in respect of the actual size and position are called aberration. So, it is a defect of the lens to form a perfect ideal image for an object. There are different types of aberrations, and first one is monochromatic aberration. The defect which occurs with the monochromatic light like defect in the size, shape and position of the images are called monochromatic aberrations. And second one, chromatic aberration. The defect which occurs due to dispersion of light or variation of refractive index with color are called chromatic aberration. Now we'll see the monochromatic aberrations and its types. There are 5 different types of monochromatic aberrations. First one, spherical aberration. Number 2, coma. Third, astigmation. Number 4, curvature of field. And 5, distortion. Now we will see what is spherical aberration. Spherical aberration is a defect in a lens due to variation of focal length for different portions, that is paraxial or marginal of wide aperture lens is called spherical aberration. And second, here there are pictorial representation of spherical aberration is considered. If the object is point object, the incident rays falls on a lens which is going to be have the deviation after passing through the lens. So the marginal rays after passing through the lens meet at P double dash, and paraxial rays meet at a different position P dash. That is, they are not going to meet at a single point. Similarly, if we have an infinite object, then the incident rays will be parallel to the principal axis. So when they fall on lens, again they are going to meet at different positions. Marginal rays meet on the principal axis near the lens, and paraxial rays, they are going to meet at far away from the lens after passing through the lens. So they are having different meeting points. So it is a defect of the lens to form a single image for a single object due to its larger aperture. That is called as spherical aberration. Next, we will come to second type of defect, that is aberration. It is coma. If the point object situated off the axis, the lens when corrected for spherical aberration forms a comet-like, that is egg-like image in place of point image. This defect is called coma and is illustrated with the help of the below figure. That is, the point object situated off the axis also, it is not going to meet at a single point, but the image will appear as a comet-like structure. Then this defect is called as coma. The third type of monochromatic aberration is astigmation. When a point object is situated far off the axis, its image consists two mutually perpendicular lines separated by a finite distance and lying perpendicular to planes. This defect of image is called as astigmation, which is shown in below figure. The fourth kind of monochromatic aberration is curvature. As you know that when you see through the picture below, the image of an object is, you look it as a curved, that is, the image of an extended object due to single lens is not a flat, but it will be a curved surface, and the outer regions of the image away from the axis are blurred. This defect of the lens is called the curvature of the field. The last type of monochromatic aberration is distortion. The variation in the magnification produced by a lens corrected for spherical aberration, coma, astigmation for different axial distances results in the aberration called distortion. So it is the magnified image is defected. That is, there are two types. One is barrel shaped distortion and another is pin cushion shaped distortion, which are as shown in the below figure. So these are different types of monochromatic aberration. Now we will see the first type of monochromatic aberration, that is spherical aberration, and the methods to minimize it. The spherical aberration is the failure of lens to form a point image of a point object is called spherical aberration. It arises due to large aperture of the lens. When the aperture is large compared to its focal length, the lines of light rays refracted through different zones of lens surface do not meet at a single point on the axis because due to spherical shape of lens, the focal length of the lens is different for different zones of lens. As it is illustrated in the figure, the point object is at infinite distance, the incident rays will be parallel. The paraxial rays meet at Fp and the marginal rays meet at Fm, and the intermediate rays are focused at the points between Fp and Fm. If a screen is placed in between Fm and Fp, then there will be an image observed as a circle is observed on the screen. Then we have to note down the radius of this circle, which gives the measure of lateral spherical aberration. So let us consider there are two types of spherical aberration, longitudinal and lateral. First we will see the longitudinal or axial spherical aberration. For the point object O is placed on the principal axis as in above figure. IP is image point for paraxial rays and IM the image point for marginal rays. And the intermediate points meet principal axis between IP and IM is called the axial or longitudinal spherical aberration. That is, when the image is at IP and IM, the distance between these 2 points is the measure of axial or longitudinal spherical aberration. Similarly, if the screen is placed perpendicular to the axis between IP and IM, image is a circular disc which is observed on the screen. The size of this disc is minimum at a particular position AB where paraxial and marginal rays intersect. The disc of the diameter AB is called circle of least confusion and the radius of this disc is called lateral or transverse spherical aberration. So, the radius of this circle of least confusion is a measure of lateral spherical aberration. Now, you came to know about what is lateral spherical aberration and longitudinal spherical aberration. Then we will see how you are going to reduce the spherical aberration. So, there are some methods to minimize the spherical aberration, among which we have listed some methods. First one, by using stops. That is, the spherical aberration is due to its larger aperture. So, we will reduce this aperture. Aperture means the area of the lens which is open for the light to incidence or light to fall on it. So, if we reduce the aperture of the lens, then we can minimize the spherical aberration. That is by using stops. Either you can close the marginal rays or you can stop the paraxial rays. Second method is the proper choice of the lens surface. Third one, using plano convex lens and concave. Convex surface should face the parallel beam of light. That is, using plano convex lens and a convex surface should face the parallel beam of light. And fourth method is the combination of two lenses separated by a distance equal to difference between this focal length. Fifth one, the combination of properly shaped suitable convex and concave lens. So these are the some methods to minimize spherical aberrations. So at the end of this session number 11, in respect to aberrations, you are able to answer the questions like what is aberration, what are paraxial and marginal rays, what is monochromatic aberration, chromatic aberration, And types of monochromatic aberrations: spherical aberration, coma, astigmatation, curvature, and distortion. And what are stops? Principal axis, focal length, circle of least confusion, longitudinal and spherical aberration, and lateral aberrations. Thank you.